Let's talk about even functions and odd functions. Let me give you the definition of each. An even function is a function whose graph is symmetric about the y-axis. Okay, now think about what that means. If you are symmetric about the y-axis, then if I have a point A comma B on my graph, I would have to have another point negative A comma B to have that type of symmetry, and it would have to happen for every pair of points on the graph, unless your point was exactly at the origin. Okay, so if you take a look at this thought, then an even function could be like a parabola, or it could be a shape like this, or really anything of the sort that has y-axis symmetry. And if you recall, we talked about symmetry types earlier in the module. So this symmetry type is obtained algebraically by noting that your function at a negative x coordinate would have to be the same y value as your function at a positive x coordinate. And this would have to be true for everybody in the domain of your function. So if you glance at the example, consider the following point, the ordered pair 2, negative 3. Find the coordinates of a second point on the graph of a function f if the point 2, negative 3 is on the graph and the function is even. That means that if x equals 2 produces y equals 3, then y equals negative 3, then x equals negative 2 would also need to produce that same y coordinate. Okay? All right. An odd function is a function whose graph is symmetric about the origin. And if you have symmetry about the origin, if you think back to your symmetry test, then for each x coordinate that produces a y, you would have to have a point negative x, negative y, or to use our AB notation here that we had earlier, if I have a point AB, then I have a point negative A, negative B. And this would have to happen, for the entire graph, so for every ordered pair. Okay, so if this is the case, your symmetry test would be that f of negative x and f of positive x are opposites. And again, you're looking at the domain of the function, the parameters of the domain. Okay, so look at the question below again, and I'll repeat it. If you have the ordered pair 2, negative 3, then find the coordinates of another point on the graph of f that would make the function be an odd function. So if I have x equals 2 producing y equals negative 3, then I would have to have x equals negative 2 producing y equals positive 3. The opposite of x produces the opposite of y if your function's odd.